Hi Pre-Calc, we're on 2.5 now. What we're going to do for 2.5 is that we are going to factor a higher order polynomial. That is quite difficult to do. It's not like you can use your basic factoring rules, or you can use every now and then you can use factor by grouping, but most of the time it doesn't work. So this takes a lot of skill to do this. The first time through, don't get upset with yourself if you just are really struggling to understand what I'm saying. It has a lot of concepts. You need to use a lot of skills to figure it out. So just do the best you can first round through. I'll do another example, and then sometime next week I'll pick one of your homework problems and I'll work it out for you so you can see a third example, okay? But just grab as much as you can from this. Some students end up really liking this. This is maybe one of their favorite sections in the course. So just give it a chance, even if it looks like a little too much at first. Okay, so Descartes' rule of signs is going to approximately tell you how many real zeros this function has, how many positive real zeros, and how many negative real zeros this has. So when you factor this, it could be a combination of real zeros and complex numbers, or just one or the other, okay? So Descartes just talks about real zeros. The possible number of positive real zeros is the variation in sign of f of x. All right, so I'm going to take f of x and I'm going to look at how many times it changes sign. A variation in sign, if you're not clear what that means, it means it's going to go from a positive to a negative, or a negative to a positive. So here I go. This goes from a positive to a positive. There's no sign change there. This one goes from a positive to a positive. There's no sign change there. This one goes to a positive to a positive. There's no sign change there. So that means that when I factor this, there's no positive real zeros, which is good to know, and I'll show you why later on. So there's no sign change, which means there's no positive real zeros. All right, let's now do negative real zeros. So that means that it's a real number, but it's negative, okay? It's the negative part of the real numbers. All right, now to do the negative real zeros, you need I'm just trying to write out the rules for you as I do this. You need the variation in sign of f of negative x. Okay, variation sign of f of negative x. So that means I have to put a negative x everywhere there's an x. So in the original function, everywhere there's an x, I'm going to put in a negative x. All right, negative x cubed. If it's an odd power, the negative comes out. If it's an even power, the negative goes away. Right? Because two negatives make a positive. All right, so now I'm going to count the variation in sign. So this is one change because it goes from a negative to a positive. This is my second change because it goes from a positive to a negative. This is my third change because it goes from a negative to a positive. All right. Now, this is going to drive you a little crazy, but the answer is 3 and 1. And the reason why it's not just 3 is because Descartes' rule of signs cannot take into account complex numbers. It cannot tell if, when you factor this, if it's got complex numbers in it. And if you do, they come in pairs. They come in pairs. So that means that there could be a pair of complex numbers here. Instead of it being 3 real zeros, it could be 1 real zero and 2 complex numbers. All right, I know that's really confusing, and I will keep stressing it, but if you notice in the rule, it says the number of positive real zeros is equal to the number of variations in sign or less than that by an even integer. Meaning, if you subtract 2 and subtract 2 and subtract 2. Same thing with the negative x, less than that by an even integer, which means you can subtract 2. I'm trying to tell you the reason why you subtract 2 is because this Descartes' rule of sign cannot account for complex conjugates. So what I'm saying is, let's say you start with 8, then write 8, 6, 4, 2, 0, right? You just keep subtracting 2 until you can't anymore. Don't give me any negative answers. If you start with 7, then write 7, 5, 3, 1. If I subtract 2 again, I go to a negative 1, which you won't have. So just subtract 2 as far as you can till you get to the end. All right, so this is Descartes' rule of signs. I have no positive real zeros. I have 3 or 1 negative real zeros. So let me sort of make a little table for you to explain to you what we just found there. So just keep hanging in till it makes sense. That's what you have to do. You kind of have to, like, you know, when I learned to swim, I just had to keep staying in the water. You know, I was treading for a while, couldn't figure it out. And then after a while, you just keep at it and you figure it out. I mean, a lot of life is just keeping at it. If it's important to you, keeping at it till you figure it out. Okay, now, how many zeros you have in total is dependent on the degree of the polynomial. So since this is a third degree, that means that this has 3 answers, or 3 zeros. So what Descartes' rule of sign does is it gives me some scenarios. It's not going to give me the exact answer, but it's going to give me the exact answer is going to be somewhere in the scenarios. So instead of taking all the possible scenarios in the world, which is an infinite amount, it's going to limit me to 2 or 3 or 4. Okay, so even though it's not exact, it's definitely funneling down all your options. You know, if you go to a restaurant, you can order anything you want. That's different than somebody saying, well, you know what, you've got to pick one of these 3 dinners. That's your choice: dinner 1, dinner 2, or dinner 3. Right, so even though it's not an exact answer, it is getting you closer, way, way closer to the exact answer. All right, so the idea is since this is a third degree polynomial, it has 3 zeros in total. So how this can break down is, for this particular problem, this will never have any positive real. So I can say I have 0 here. But in terms of negative zeros, it could have 3. That's one case. And if it has 3, since the total is 3, that particular case means that that would have 0 complex. Because that would, what that adds together, that column adds to be 3. So this would be like case 1. Ooh, I'm probably gonna have to break this into 2 videos. I'm looking at the time. All right, case 2 No matter what scenario, this has no positive real zeros, so I'm going to put a 0 here. It's going to have, it could have 3 or 1 negative. So let's talk about the case where it has 1 negative. If it happens to be this scenario, then for this to add to 3, I must have 2 complex zeros. Right? And they come as complex pairs, so it has to be always be a 2, a 4, a 6, or something even here. Okay, so the only way this answer is going to break down is this case or this case. And I will come back to this and show you why this is important. Let's just move along. If I get cut off, and I'm sure I will, I'm going to pick it up on the next video. Okay, the rational zero test. The rational zero test, the best way to describe this, and my students always make fun of me because I don't really know football very well, and I always use football as an example, which may not be clever on my part, but the rational zero test is like how in football, and again, I don't understand football, so if you understand football, you're going to be like wheeling this crazy, but you know in football, you start with a whole bunch of teams, and then at the end, somebody wins, okay? Somebody wins the season. So what the rational zero test does is it generates the teams. And then you figure out through your math skills who the winner is, okay, like this. So this is how you generate the teams, okay, or generate your potentials. You take the constant over the leading coefficient. Don't worry about the plus or minus. How you do it is you take the constant over the leading coefficient. All right, now the constant in my case is a 6, and the leading coefficient is a 1. Now, this is not a fraction in the standard sense. So like if this were be a 2, I wouldn't reduce this. Don't reduce this. What you want to do is list all the factors of 6. So the factors of 6 are that, and the factors of 1 are 1. Now, I'll do another example where there's more combinations here, but basically you want to do combinations. Everybody in the top combined with everybody in the bottom. But there's only one option here. So there's only one number in the bottom, so there's not a lot of combinations I can do. So you're going to put everybody over 1. If there had been a 2 here, you would have then put everybody also over 2, and then you put a plus or minus in front of everybody. So just to make this look better, so these are the teams. I've generated the teams. So it's, there's 8 possible teams, right? There's 2 plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So the answer is in here. We just have to find it, okay? If it's a real, if this function has a real 0, which we know it must at least have 1, maybe it has 3, it's going to be in this list. All right, this video is like at 3.5 minutes, so I'm going to end it here so I don't get cut off mid-sentence. I'll pick up on this problem in the next video. Catch you. Bye-bye.